Syahinda binti Abdul Majid and my matrix number is 2022456842.
My name is Nur Alia Akila binti Muhammad Effendi and my matrix number is 2022499384.
My name is Noira binti Muhammad Rafi and my student ID is 2022680856.
Hi, my name is Amira binti Saari and my student ID is 2023602868.
Assalamualaikum warahmatullahi wabarakatuh. I'm going to talk about the introduction of the topic. When an object is pulled up a rough incline, work is done against friction and gravity. This topic looks at how to calculate the energy used to overcome these forces as the object moves along the slope. In this question, we are finding the total work done to pull an object up a rough slope. The force pulling the object has to overcome two things: friction between the object and the surface, and gravity pulling it down the slope. So, my friends will explain how to calculate the work done against both friction and gravity as the object moves upwards.
So here is the problem statement. A rough surface is inclined at tangent -1 3/4 to the horizontal. A body of mass of 18 kg is pulled in a uniform speed at a distance of 40 meters up to the surface by a friction acting along the line of the greatest slope. The coefficient of friction between the body and the surface is 1/5. So here we need to find the work done against friction and the work done against gravity.
Before we answer the question, I do the vector equation based on the body diagram that my friend already do. This equation represents the equilibrium of force acting on an object. Since the object is in equilibrium, the total force acting on it must be zero. Now, let's focus on the y component of the force equation. R minus ATG equals theta equals to 0. This equation comes from the vertical y direction forces. Since the object is in equilibrium, the total vertical force must be 0. We rearrange the equation to isolate R, the normal reaction force. R equals to ATG equals theta. Now we substitute the known value. The mass is 80 kg, G is 9.81 meter per second square, and from the equation, the angle cosine is 4/5. After that, we multiplying everything give us the value of the normal reaction force, which is R equals to 627.84 Newton. So the upward force from the surface acting on the object is 627.84 Newton. Right now, we still can't solve the question yet because we need to calculate the frictional force using the formula. So the formula is mu R. Given that the coefficient of friction mu equals to 1/5 and the reaction force R that we already calculated is 627.84 Newton. We need to substitute the values into the formula. 1/5 times 627.84 and we got the answer 125.568 Newton. So the frictional force acting on the object is 125.568 Newton. Now we can already answer the question A, which is they want us to find work done against friction. Now we need to calculate the work done against friction. We use the formula work equals to mu R times distance moved. From the previous slide, we already found that mu R equals to 125.568 Newton and the object moved a distance of 40 meters based on the question. So, we multiply 125.568 times 40 and we got the answer 5022.72 joule. This means the work done to overcome friction over 40 meters is 5022.72 joule. This time, we're gonna answer the question B. We calculating the work done by the component of weight acting along the slope. We use the formula work equals to force times vertical distance moved. The force here is the component of the weight down the slope, which is 80g times sine theta. And the object moved 40 meters along the slope is given that g equals to 6.1 meter per second square and sin theta equals to 3/5. We substitute into the formula 80 times 9.81 times 40 times 3/5, and we got the answer 80,835.2 joule. So the total work done by the gravity down the slope is 188835.2 joules.
Our conclusion by the concept of work, energy, and power are fundamental in analyzing motion and effects of force on objects. Works explain how a force causes displacement, while energy represents the capacity to perform that work through motion such as kinetic energy or position such as rotational energy. Power are measured by how quickly that work is done. Thus, this concept helps us to understand and predict the behavior of mechanical systems from simple machine to complex structure by ensuring efficiency, stability, and control in mechanical designs.